So now that we have these trigonometric functions, right, and some basic formulas, let's see what we can do with these things. Right, so we're going to start, just a very basic question. It's called solving a triangle. And the idea is, I know some information about a triangle, and I want to fill in everything else. Specifically, I'm looking for all of the other dimensions of the triangle, both in terms of the sides and the angles. Okay, so in this case, I'm talking about a right triangle. So let me draw that, right? I'm going to do a right triangle here. And what do I know about this thing? Well, the hypotenuse is 10 inches, and one of the non-right angles is 35 degrees. And I want to fill in everything else, right? Specifically ask for the lengths of the two sides, but it's easy enough to get the other angles. Matter of fact, I'll go ahead and do that first. All the angles in the triangle add up to 360 degrees, so let me label these A, B, and C. So the measure of angle A must be 360 degrees minus angle C, that's 35 degrees, minus angle B, that's the right angle. So that's 90 degrees, which means my missing angle, angle A, let's see, 360 minus 90, that's 270. That's going to be, oops, sorry, it's not 360 degrees. Triangle is 180 degrees. That's more like it. So this is 90 minus 35. That's 55 degrees. So let me fill that in. 55 degrees. And now we can talk about the sides. So to do that, I'm going to use, excuse me, our trigonometry ratios, right? So let me give some variables here. Let me call this one x and this one y. So it's basically pick the ratio you want to use, right? I'm going to say, let's see, the sine of 35 degrees equals, that's opposite over hypotenuse, so that's x over 10. So that means x is 10 sine 35 degrees. And for these practical questions, we're always going to kind of end up going to our calculator, right? My calculator tells me that this is going to be 5.74 inches. And so that is this side. All right, now I'm going to do the same thing, right? I'm going to do the same thing to find the value of y, but this time I'm going to do y over 10. That's adjacent over hypotenuse, so that's going to be the cosine of 35 degrees. So y is equal to 10 cosine 35 degrees, which is 8.19 inches. And that is my third side. And that's what I was asked to find, right? I've filled in the two missing lengths, two missing side lengths in this triangle. Okay, so now we're getting a little more practical, right? We have a radar station, and it records an airplane with an elevation of 23 degrees. So let me start sketching this. I'm going to do the ground here, and I have my radar station. And I have a plane over here somewhere. And let's see, so what do I know? The angle of elevation. Remember, how do we get the angle of elevation? If you start at the ground and go up until you get to the line going out to the object, that's the angle of elevation. So this is going to be 23 degrees. And I know there's another radar station 10 miles from the first that reports the plane directly overhead. So I have another station here, and it's directly overhead of this one. So what I want to know is, what's the altitude of the plane? Let me fill in that distance here. This distance is 10 miles. Okay, and directly overhead means that this is a right angle. Right? This angle is 90 degrees, and that's great. I've got a right triangle here. Right? Anytime I got a right triangle, I can get out my trig ratios and hopefully get an answer. So what am I looking for? I want the altitude of the plane. Right? Let's call it A. And so what do I know? I know this adjacent side, and I want to know the opposite side. Well, opposite divided by adjacent, that's the tangent, right? So this is the tangent of 23 degrees. And I'll multiply both sides by 10. And then I'll get out my calculator, and this comes out to 4.24. And the units here are miles. So it's flying pretty low, right? Altitude of just 4 miles up in the air. Okay. You can give this one a try, right? Try this one out. See what you come up with, then we'll do it together. All right, so what do I have here? Again, right, I'm going to start by drawing a picture. So I've got the ground, and I have this tree here, and I have a person, and he's standing over here. And, okay, so what do I have for distances? He's standing next to a tree and walks 20 feet away. So this is 20 feet. And from that point, the angle of elevation to the top of the tree is 48 degrees. So he's holding some kind of device here, and he's getting this angle of elevation to the top of the tree. And we're doing this from eye level. So this is 48 degrees. And the person is 5 feet 7 inches. And I'm looking for that for the height of the tree. Right, so I want this height here. Well, I can't find that directly, really, because I don't have a right triangle coming off of that height. But look, what I can do is I can find this height, right, because that is a right triangle. Then I'll just add in the height of the person. Right, so let's see, how am I going to do that? Well, I know, see, what can I call this? Let's just call this x. So relative to that 48 degree angle, I know the adjacent side and I want the opposite one. Right, so that's going to be the tangent. The tangent of 48 degrees is x divided by 20. So x equals 20 times the tangent of 48 degrees, which, excuse me, my calculator tells me is 22.2 feet. All right, so that is this here, and that's in decimal feet, right? So what I want to do to get this actual answer, the final height, I want to take 22.2 feet and add 5 feet 7 inches to it. Well, I really can't do that because I can't mix and match my units. So what I have to do is I have to take that 5 foot 7 and convert it to a decimal value. So it's going to be plus the 5 feet plus the 7 inches. That's 7 divided by 12 feet. And again, you go to your calculator. This is 27.78 feet, which, if you prefer, right, this is 27 feet 9.36 inches. Either one is a fine way to write the answer. Okay, so what's next? Well, those are actually some relatively basic questions, right? Just kind of playing off of your basic right triangles. So in the second lecture in this sequence, we're going to kind of look at some little more complicated problems, some things that are a little more interesting.